Our next three definitions are right-hand limit, left-hand limit, and two-sided limits, okay? So our right-hand limit, the notation, students, is limit as x approaches a value. Let's call it c. Now, to denote that it's right-hand limit, we do a plus sign as a superscript, okay? So something's wrong with my pen. So f of x as x approaches c plus is the notation for right-hand limit. So now this is red. The limit of f of x as x approaches c from the right. Now, left-hand limit notation, students, is going to be the limit, and then x approaches c, and then the superscript is the negative of our function f of x. So this is red, the limit of f of x as x approaches c from the left. Now, two-sided limit is exactly the same. The notation is exactly the same as what we wrote down in the very first definition. But here's a big but. The limit as x approaches c of f of x, students. This could only exist, This could only exist if and only if. So IFF stands for if and only if. The limit as x approaches c from the right of function f of x is identical to the limit as x approaches c from the left of that same function. So what this means, my pen is frozen. This means that for the two-sided limit to exist, students, the right and the left must be exactly the same. And this is so important, guys, So for this to exist, the right and left must be exactly the same. So let's demonstrate in this next few examples. Example 3 says complete parts A, B, and C for the piecewise function defined. Here, f of x, we have two pieces here. First piece, 3 minus x, only when x is less than 2. Then the second piece is 1/2 x plus 1 when x is bigger than 2. You can graph this multiple ways, You can make a table. You kind of figure out, well, I'm going to start with start with positive 2. Then if it's less than, I'm just going to pick values that are less than 2, such as 1 or 0. So when x is 2, it's going to be an open circle since this is not an equal, So 3 minus 2 is 1, open circle. 3 minus 1 is 2. 3 minus 0 is going to be 3. So 2 up 1, open circle. So that's not 2 up 1. 2 up 1, open circle. 1 up 2, 0, 3, and keep on going. Remember, this has a slope of -1. So if I have a slope of -1, I can technically keep on going and use your straight edge. Let's connect those. So that's that way. And then we do the same thing for the second piece. We again pick a value of 2. It's still going to be an open circle. So 2 divided by 2 is 1 plus 1 is 2. And then I'm going to pick values that are bigger than 2, But I'm going to pick smart values that are divisible by 2. So 4 divided by 2 is going to be 2. 2 plus 1 is 3. And again, we can think of this as the slope as 1 over 2. So 2 over 2 up 2, open circle. 4 up 3, the slope is 1 over 2, so technically I can just make the next dot, use a ruler, connect those dots, have an arrow. You can always go beyond the grid. So part A, we drew the graph. Part B says, determine the limit. So now let's read this. The right-hand limit as x is approaching 2 of this function. So the right-hand limit, meaning that you're going to be coming from the right side. So the limit as x approaches 2 from the right of our function. So the right is over here. I'm standing on the right side. I'm going to walk towards 2. Remember, 2's are here. So I want to know, what is the y value approaching? Okay, remember, the limit doesn't say that it has to equal. It could equal, but what is it approaching? So when I'm getting closer and closer to 2, coming from the right side, the y value is going to be 2. So this right here equals 2. Now, second half says, find the left-hand limit. The limit as x is approaching 2 from the left side. Well, the left side, remember 2 is still right here, okay? So that means I'm standing on the left side of 2. I'm walking closer and closer to that side. Now, as I'm walking closer, this right here, it's on 1. So this y value coming from the left is approaching 1. Based on that definition, students, okay, does the limit exist at 2? Now, based on our definition, this limit only exists if the right and the left are exactly the same. And based on what we just got done, they are not the same. So therefore, no, okay, because left and right hand limits are not the same. Right hand limits are not the same.